Comparing functions less than 13 notes. In example number 4, we talked about the y-intercepts. Y-intercepts have x equals 0. So for all y-intercepts, x equals 0. And remember, a y-intercept is where the function would cross the y-axis. Well, functions also have an x-intercept. And x-intercepts are where the functions cross the x-axis. It's the point at which a function crosses the x-axis. So pause your video and get this definition written down. Okay, so again, the y-intercept has x equals 0. For y-intercepts, x equals 0. Well, for the x-intercept, the y-coordinate is 0. Y equals 0. Pause your video, get that written down. Okay, so here are some examples of x-intercepts. Any number could, or any ordered pair could be an x-intercept as long as the y is 0. So 3, 0 would be an x-intercept. -2, 0 would be an x-intercept. 1/2, 0 would be an x-intercept. -5.8, 0 would be an x-intercept. In all of these examples, y equals 0. Okay, so if you have all that written down, let's look at example 5. In example 5, it says, Lexi and Brookson leave Kennywood at the same time. Both drive home at a constant speed. The table shows the function that models Brookson's trip home. The graph shows the function that models Lexi's trip home. Who got home first? Well, this is what's important. When you're home, your distance from home is 0. When you're home, your distance from home is 0. Okay, so your distance is 0. If you look at Lexi's graph, if distance is 0, what does that mean? That means you're finding the x-intercept. Pause your video and get this written down and this. Okay, so again, if you are home, then the distance from home is 0 because you're home. So we need to find the x-intercept. Well, for Brookson, it's really simple because right here, well, it doesn't show it very well. Let's pick a brighter color. Right here is the distance from home. So I find where the y value is 0, and I'm going to box that. So you do the same thing. All right, so there's no work involved for Brookson. All right, so how long did it take Brookson to get home? Well, right there. It took him 5 hours. So if you are looking for the x-intercept, your y value will be 0. If you're looking for the x-intercept, your y value will be 0. This right here, that's your y-intercept. Okay. Now, for Lexi, again, you're finding her x-intercept. We want to find the x-intercept. So looking at her graph, well, first of all, this right here, this is your y-intercept. Down here is the x-intercept. So for her x-intercept, it's 4 hours. So Lexi, it took her 4 hours to get home. So who got home first? Who has the quicker time? Lexi did. Lexi got home first. All right. Now, we're going to also find the unit rate or the rate of change here. So for Brookson, his rate. Well, how many total miles did he drive? Well, before he leaves, it's 180 miles. And as he's driving, the distance decreases. Because as you drive home, your distance from home goes down. So he traveled 180 miles in 5 hours. He traveled 180 miles in 5 hours. So what was his unit rate? What was his rate of change? Well, 180 divided by 5 would give me 36. So he drove at a rate of 36 miles per hour. Yeah, he drove pretty slow. So even though his distance was 180 miles, it took him 5 hours because he drove 36 miles per hour. All right, let's find Lexi's. Well, what was her starting distance? 200 miles. And as she drove home, her distance decreased because it was the distance from home. So she was 220 miles in 4 hours. So her unit rate, which is her rate of change, divide that out and you get 55 miles per hour. So even though she drove a good many more miles, she got home first because she drove at a rate of 55 miles per hour. So she drove at a rate of 55 miles per hour, while Brookson drove at a rate of 36 miles per hour. So that's why it took him 5 hours and it took Lexi 4 hours. Therefore, Lexi got home first. All right, that is it for example 5. If you have any questions, please let me know.